Yeah, so we have a couple reasons for adding scripting to Synthesizer V. So the subject is actually about Synthesizer V Studio, our voice synthesis plugin. But this talk, I'm not going to explain in great detail why we're adding scripting support to it. In fact, your dev might be really interested or getting really bummed when you're trying to talking about adding scripting support, but that's probably not a good idea if you're just thinking, oh, scripting is cool, have everything customizable. It's a huge undertaking and it's adding a lot of technical depth. But the decision was made 6 years ago when I was still one main company. I started working on Synthesizer V Studio, and I was trying to just try to pack as many features into this thing as possible, slap the top of Synthesizer V Studio. So it actually turned out to be a quite interesting decision if you think backwards in the day of 2025. Because the software has evolved a lot throughout these years. When we first started, it was actually based on sample concatenation. There was no AI, no neural network. And then later, the whole engine got rewritten. So a lot of new features being added. We swapped the whole thing with neural networks, and a lot of new people came in. The old users also stayed. So now we have a lot of different users basically having different workflows, and we're often surprised by some of the new workflows and some of the new use cases. Taking example, this is actually a real story. We just had this literally come into a customer support a couple of weeks ago. So there's a music teacher, and she likes to fill in the lyrics with suffixes like do, re, mi using shortcuts. So they can demonstrate the music theory and composition skills without having to, draw the whole score and enter the lyrics one by one to just get some audible result. I want to show the interface of the software just to give you a more concrete example of what I mean by this. So here's the interface of Synthesizer V Studio, where you have this piano roll. You can enter a whole bunch of notes, and by default, the lyrics are just la la la. You choose a voice and you press spacebar to play. La 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 la. Oh, this timing is a bit off, but I can fix it like this. I can just double-click a note, enter lyrics like, I can say scripting architecture for DAW-like plugin. So if you just enter lyrics and play, it's gonna be like scripting architecture for a DAW-like plugin, la la la. So what the user wants to do is to have a shortcut so they don't have to enter all these lyrics one by one. If you just enter something like do, re, mi, and the lyrics just become like that, it'll be good for just demonstrating, how to come up with different melody lines, how to maybe create harmonies, how to just add a whole bunch of notes on the composition level. So the good thing about having scripting is that now in 2025, everyone's talking about vibe coding. You can just literally ask ChatGPT or Cloud AI. Basically, all I did was just copy-pasted the user story to ChatGPT and paste them. Very importantly, pasted like a link to our scripting documentation. We have this page on our server. So this is our scripting manual. You can click into, like, for example, Node, and you see like all the method all the things you can play around with nodes. Yeah, so it's just as straightforward as you can scan the QR code to actually have a look at the conversation. It's not very long. It just took me like 2 or 3 rounds of conversation with ChatGPT to actually got this new feature up and running inside Synthesizer V Studio. Almost like no coding from my side. The end result of that is, so I can just select all the nodes, go to scripts menu, I have new script. So this feature is entirely coded by ChatGPT. I just click this, including this interface. ChatGPT designed this. You got a few selections whether you want to go with a kind of Americanized pronunciation or a more Italian pronunciation. You can like change the mode, the tonic, yeah, and if just leave it default, press OK. Mi, mi, fa, so, so, fa, mi, re, do, re, mi, re, do. Yeah, so like this whole feature of filling notes with lyrics was coded by ChatGPT in JavaScript. Yeah, you can just scan the code to actually have a look at the code it generated. So this is just one of the application of scripting. Obviously, there are some workflow benefits. For example, you can use to automate software testing. A lot of things you can do. So let's have a look at the script it actually wrote. So this is like an excerpt taken from the JavaScript. In total, just about 100 something lines. You can see this is an object-oriented scripting architecture where we have the abstraction for basically pretty much everything inside Synthesizer V Studio. You have both the project data, like the nodes, and also the UI data, like the main editor, the selection, get to select the nodes, and you can modify stuff, and everything is an object, basically. So if you look at this and you're thinking about how we're going to implement this type of scripting architecture, immediately you can think of a lot of questions. For example, how would you expose the data from the host? So here, host, I mean Synthesizer V Studio. So it's not the DAO it runs inside. So the host, how do you expose data from the Synthesizer V Studio as script object you can access as JavaScript Lua variables? How do you call the script functions? How to call functions from the native code, like in C++, from the script, including like get pitch, set lyrics, and how to transfer these return values from the native code back into a scripting environment. So before we talk about how to implement this, let's have a look at what we need to design. So try to take a step back and think about the design requirement a bit more clear in this bullet point list. In our case, the program supports both Lua and JavaScript, but this was the reasoning was actually I didn't actually have that much reasoning behind it, except that in the beginning there was some technical issues with certain JavaScript features and with Lua features. So I felt maybe it's safer to have as many scripting support as possible. But later I found this actually resulted in a more robust system that can be fairly quickly extended to other scripting engines. Other things we're trying to do, basically trying to make the scripting system as powerful as possible. But being powerful isn't the only thing that's important. Equivalently important is being easy to use for the users who may not be expert at programming. So we want the whole system to be object-oriented instead of being more like command kind of a model, where you have to type in lengthy function names and So also another prerequisite is you want your program first to be structured, I guess, fairly clean in terms of the model view separation. So the software architecture for Synthesizer V is like model view model, but let's not talk about view model or equivalent to controller in typical MVC setup. But what's most important is you have to separate the view from model. For why this is important, if you look at what data in the model we have track, we have node group, which is like clips in certain DAOs, and inside node groups there are nodes. They can be referenced by multiple view components. So a node could appear inside a piano roll. It can also appear in the arrangement as a thumbnail. Now, if you're modifying, say, dragging a node inside a piano roll, you don't want piano roll to talk to the arrangement to also like please update the arrangement thumbnail. You don't want to have an arrow from here to here, because when you're adding another like view that talks to the node, you have to repeat everything again for that one. That's just too much work and it will make everything super messy. Based on this, I guess this kind of architecture is fairly common, but based on this one, when you're adding a script, you're really adding another branch to this instead of having a script attached to the view side. So how this is actually going to work is the script controller is going to modify the model, and say the script creates a new node, and then your model talks to your view, hey, please actually give me a new component for that node, instead of the other way around. Right, so it's not like the script talks to the view component, add me a new node bar, and then the node bar adds a new node inside your data model. Otherwise, it's just going to get messy if you have multiple views, the same model. Then next step is let's have a closer look at what happens inside a script controller. So one of the things we're doing here is having support for both Lua and JavaScript, which proved to be quite helpful when later when the large language model became a thing, and everyone's just vibe coding JavaScript, not Lua. So what's important here is since we have multiple scripting backends or scripting engines, we don't want to rewrite the whole script binding with the model again for each of the new script language added. So we took another step of abstraction. So there is a base class for a two-script engine, which we call the script object factory. Remember, our scripting model is totally object-oriented, so there has to be something that creates objects. So we call it the script object factory. Most of the bindings are done between the model and the scripting object factory, and the object factory exposes a few virtual methods for the script engine to define based on the usage and the behavior of the particular scripting language or the implementation, the interpreter of that language. Now we have this basic structure. The next thing is how do we get data into or out of the script engine? So the application is written in Juice, and by the way, Juice did have or does have a scripting engine in JavaScript, but when we started to work on this, it was Juice 5, and back then the JavaScript engine was like implement from scratch. It's implement a tiny subset of JavaScript features, so it wasn't very useful, which is why we had to introduce duct tape into this engine and do all the binding ourselves. But we did reuse some of the features from Juice var, which is very much compatible with those dynamic typed Java or Lua objects, because while I was seeing the screenshot, you can just basically given a Lua integer, just pushing integer into the word, given a Lua boolean, just put a boolean into the word. And the same happens for the string and for the array. What is tricky though is how do you wrap functions and how do you wrap C++, larger C++ classes like a node class or group, a track. So let's first look at the functions. Just wrapping a single host function, like for changing the third node on the second track, isn't hard because obviously all script engines pretty much support native language, native function bindings. So if your script is based on interaction like this, so if you just have one function assigned into each of them, the things you can do with the objects, it's pretty simple. Just repeat the definition for all functions. Everything you can do inside your model, then it's done. But obviously, this is easy to implement, but it's not easy to use. And also, you have to implement this again for all the number of script backend you have multiplied by the number of functions you have. We rather want it to be object-oriented, so you actually do like track.getGroup and do a group.getNode and do node.setLyrics. So the question here is, since we earlier talked about we're wrapping everything inside Juice var, and inside of Juice var, obviously the function pointer isn't unique, it's dynamically allocated. So how do you actually bind that with the JavaScript engine? So what we do is we actually have a global function binded, and that function's sole purpose is just to basically grab the function pointer from the script object, and also get the calling object, and then dispatch that into the relative function that you actually want to call inside a host. The next thing is about object. So, I think I actually have the two slides reversed. Should start this one first. Sorry. Next thing is about wrapping the host object. So inside a program, you could have the user could have created a node, or you could have the script create a node. But what happens, say, if the user deletes the node that the script creates, or if the script deletes the node the user creates, and then the user undoes, and then you don't want it to suddenly crash because the script's trying to access the deleted node. When you try to unpack this kind of situation a little bit, really, there are just two cases. So here, if we try to clean up the terminology a little bit, I'll call like, we'll have this distinction of managed versus unmanaged objects. So basically our definition for unmanaged objects is the object owned by the host. So in this case, you're trying to get a node created by the host, and the script tries to remove it. And when the script tries to access a removed unmanaged object, it shouldn't result in like dereferencing a null point or a deleted point or anything. It should just detect that the object has been deleted by either the script or the host, and it should give you an error instead of crashing. The other case is, so if the script creates an object, we call it a managed object because it's garbage collected by the Lua or JavaScript engine. When you actually stop referencing that object inside a script environment, it should be GC'd unless the object has been added to part of the host document tree. So there's a certain kind of transition between the managed object and unmanaged object. By the point you're adding it to an unmanaged object. Once we're clear with logic, obviously you could just literally implement like explicit state transition when add node happens. But then you have to do it for pretty much all similar methods. Like we can have add track, add group, or add mixing or whatever thing you can add to it. But that is just too much work. Our way of dealing with it is to make it passive. So this is like a trick, borrowing some fundamental building block like shared pointer and a weak pointer. But basically what will happen is we reuse the juice reference content object and use it as a wrapper to the host references to the actual host object we want to safely access. And inside it, there are like a pair of pointers. One is a shared pointer, one is a weak pointer, pointing into pretty much the same thing. And by comparing the usage counter of these two counters, you can actually tell the state of the object. So whether it's being owned by the plugin, by the script, or it's being owned by the host. And yeah, based on the values of the counters, you can just decide to free it or not when you're destructing this reference counter object. The last thing I want to cover is handling callbacks. So the callbacks are tricky. There are just a lot of cases when you're considering going back and forth between the host and the script. But the simpler cases, which may not actually look as simpler, is when you have a asynchronous callback. So for example, we want to pop like a hello dialog at just any message from the script. If the API is asynchronous, it'll look like pretty much like this. So you wrap passing a anonymous or lambda function into this host method. So in this case, if you press OK, it's going to add a new track to the current project. This function only gets called after the script finalizes and quits. Because when you run this, the first time you run is not actually going to execute this function. It's only going to show a dialog, and then the script finishes. And later, when the user presses the OK, it actually gets actually calls this anonymous function you're passing through the script. This is actually simple because all you need to do is you just need to call a script function from the native code. So basically something like this. Although you would rather want to do it a bit cleaner by refactoring this into a virtual method of the script object factory instead of writing this twice for each scripting engine. What's tricky though is not all users who could be music producers, who could be hobbyist programmers, who could not know anything about programming, understand the concept of asynchronous versus synchronous processing. So most of them will be just thinking, hey, I just want to show the user a message box or a dialog asking for a value before executing the next line of code. So in that case, ideally, if the user isn't familiar with the concept of async calls and you're asking them to try some scripting, they will think the code will naively look like this, which in fact, in many cases, is easier to write if all you need, is just to insert some lyrics into the existing nodes. If you're just naively implementing on the host side by blocking the execution, obviously it's probably gonna work for standalone. But if you're working with the dialog, it's just really bad practice to freeze interrupt the host message loop, which is going to freeze the DAW's UI. So let's try to break this problem down to two parts. So the first part is just showing the message box. And ideally, there is some way to pause the script's execution so you can go back to the message loop and resume the script execution when the user clicks OK. If we're trying to look into the Lua documentation, we can actually find exactly the kind of API which support this, which is Lua yield and Lua resume. So this is not a problem for Lua, since they already pretty much has the API we need. But later when we tried to work with duct tape, we found, quite unfortunately, so 80% or 90% of duct tape API can be mapped to Lua, but it just doesn't have the same kind of API when it comes to yielding and resuming the interpreter's execution. So what we tried to do in the beginning, so that was implemented about 4 years ago, was actually use an external coroutine library called labco, to force the program out of the duct tape engine when this dialog appears, and just resume that context when the user clicks OK. It surprisingly, despite how hacky it is, surprisingly worked in most of the cases, and we shipped the program to production until we realized it only crashes context. When the context is loaded even on a different track, as long as context is loaded, you just can't run Synthesizer V. Took our QA quite a while to find the exact condition to reproduce this. This probably has to do with some DRM mechanism that's causing this kind of crashes. So in this case, we spent a lot of time trying to fix this problem. Temporarily, we had to disable the whole JavaScript engine when you're running inside the DAW. But later, we realized the key to solving this problem is we have been thinking out of the box for too long. You really have to think inside the box. By inside the box, literally inside the scripting engine. So what we did is we found duct tape actually offers their own coroutine library inside the scripting environment, which doesn't seem obviously helpful, until we thought, hey, maybe we can just wrap the whole user script inside a coroutine, inside a script environment. So what we did was get the script engine preload this wrapper. So the actual script code is actually wrapped inside main and inside this duct tape thread. In this case, you don't have to free the script engine. You just have to use the built-in coroutine library to do exact same in terms of the outcome. So pause the script execution when it needs to pause and resume it when user clicks OK. So yeah, we have covered so far an object-oriented program interface, garbage collection compatible lifecycle management, and adapter for wrapping the available async calls and synchronous calls. I guess due to time constraint, these are just some of the core building blocks for a script engine. But given this pretty robust building block, we have developed even more scripting capabilities. Like, the user can now pretty much define all kinds of UI widgets in a subpanel and link them with link the script variables with UI widget states. And yeah, you can pretty much do a lot of things. So yeah, with that, I guess I'll allocate a few more minutes to questions, if there's still time.